Hey guys, the Coaster Man here. Good to be back on YouTube. Sorry I haven't been on in about a week. I've been busy doing some other things, but don't worry, I'm back, ready to get back into our videos here. I've got a very special video for you today. Today I am going to be doing a little bit of math and science behind the roller coaster at Cedar Point called the Top Thrill Dragster. We're going to be looking at the launch station. We're going to find out how long it is, and we're also going to find out at what rate does it accelerate, and therefore it'll be able to tell us the gravitational forces or G forces you experience while being launched. So neat stuff. It does get a little intense, so if you get lost, sorry, this is kind of like high school level stuff, and like I said, if you get nothing else out of this, it's awesome to brag to your friends to say, dude, that dragster launch is like that many feet long and you experience that many G forces. So the final answers are pretty awesome, so hope you enjoyed the video. This is true roller coaster engineering, though. Roller coaster enthusiasts, you better be taking notes here. This is important stuff. Let's get started. This is so much fun. You guys are going to love it. Okay, here we go. Let the magic begin. First thing I like to do is draw a template. Okay, there's our template. I like to draw the template, and this is where we're going to put all of our information. So up here, I like to put my original distance and my original velocity. I like to put my acceleration up here, my time in here, my final distance, final velocity. Okay, so that's how you might want to set up your template. Keep in mind, guys, we're going to be using kinematic equations and dimensional analysis. So make sure you know how to, do those skills. Okay, now let's put in our values. We know at the beginning of the launch, you're at 0 meters, traveling 0 meters per second. Okay? We got to keep our units in the base form of the System International SI system, basically, metric system. But don't worry, we will convert them all to US customary to make it more awesome to brag about. So, there's our original stuff. We know that it takes 3.7 seconds to go 120 miles an hour. What a good ride. There's only one problem here, and it's that 120 miles per hour, it's not a base form of the SI measurement. So it's not ready to be put into the problem yet, unfortunately. But we can fix that with a very simple dimensional analysis problem here. So let's fix that problem and find out our velocity. So we have 120 miles in 1 hour. We got to get to meters per second. Okay, so here we go. So we know that 1 mile contains 1,609 meters. Look, 1 unit done. Let's move on to getting our hour. So we have to cross out the units. So 1 hour is 60 minutes, and 1 minute is 60 seconds. Awesome. We have our meters and we have our seconds. Our dimensional analysis problem is ready to go. I like to cross out the other units because sometimes they're just going to get in the way of trying to look at your numbers. So now we're going to, everything on the top, multiply it together, divide it by everything multiplied together on the bottom. Here's how you do that in the calculator. Pretty easy. You're just going to take 120 times 1,609. You're going to divide that by 60 times 60, or 60 squared. That is your velocity. That's your final velocity. That's how fast the coaster is traveling in your meters per second. Okay? So now our real velocity that we're going to use in solving this is 53.63 meters per second. Okay? Good. So we're done with that factor labeling problem there. And now we can just go straight into the kinematics equations. Okay? Here you go. Very simple. There's a list of kinematic equations you can use here. I'm choosing this one. I'd like to try to find the acceleration first. So let's do that. Let's get our velocity equals our original velocity plus our acceleration times our time. Okay? What is our final velocity? Remember, we have to use that SI unit one that we did with the dimensional analysis. So that equals 0. We don't even need it. Just bye-bye. We don't need you. And 3.7. A. Divide both sides by 3.7, basic algebra here. And your acceleration You're going to type that into the calculator, 53.63 divided by 3.7, and you're going to get 14.5 meters per second squared. Cool stuff. There's one piece of information done. Awesome. There's your acceleration of the dragster, guys. Let's make that even more awesome. Let's find out what the G forces you experience on the dragster. How many G's are you getting during that launch? Well, we know that right now I'm standing, in the room, wherever you're sitting on the computer, you're experiencing 1 G, okay? So we know that when you're experiencing them at 9.80 meters per second squared, this is a standard, okay? You're experiencing 1 G. How many G's are you experiencing at 14.5 meters per second squared? We don't know. Let's find out. 14.5 equals 9.8x. Let's do that in the calculator. I'll do that with you. Okay, I'll do this one with you. 14.5 divided by 9.8. That 9.8 is a standard, so if you don't know that, no big deal. 1.479, or as I just like to say, 1.5 G's. So on the dragster, there's one awesome piece of information. When you ride the dragster, you experience 1.5 G forces. That's awesome. But how long is this launching? How long does it take you to get launched to that 120 miles an hour? How long is the distance of that? Okay, we're gonna find that out now. So this kinematic equation is done. We know we go 1.5 G forces. I'll even write that there. I'll write G's is 1.5. Okay, so there we go. Oops, sorry, got to cut off the camera, but just pretend that I wrote that there. Now let's use a different kinematic equation. We got to find this distance here. We got to see what that is. And again, you can choose any one, and there's my 1.5. You can choose any one. I'm just using this one. So, distance. Do we know our distance? Nope. Distance of our original is 0, so bye-bye, we don't need you. 1/2 times velocity. We don't even need that, so just those are all base units for SI. Very simple. You just multiply this all in the calculator. So easy. So you're just going to grab your calculator, and hey, there's my 1.5. Yes. And now you're going to do 0.5 times 53.63. Why is the phone ringing? Times 3.7. Like, seriously. And you're going to get 99. So you're going about 100 meters. Or for this case, I'm just going to say 99.22 meters. So the distance is 99.22 meters of the launch pad. But do we really know what that is? Not really. I mean, I don't. I don't know. Like, if someone said, how long is that? It's about the length of a football field, but, I mean, why don't we just convert that to feet? You know what I mean? I mean, let's convert that to feet right now. I mean, that's so we know it's 99.22. Let's get that to feet. That's 99.22. Not so braggable. Let's make that awesome. Okay? 1 meter. 100 centimeters. 2.54 centimeters. 1 inch. 12 inches. 1 foot. Good. Now let's figure out what is the length of that launch pad. How long in distance does it take for you to go 120 miles per hour? Awesome question. Here's the calculator again, so that way you guys know how to do it at home. This time, I would recommend using parentheses. Parentheses, 99.22 times 100. And that parenthesis divided by 2.54 times 12. Bada boom. 325.5 feet. 325.5 feet. That's how long the dragster is. And you experience 1.5 G's. Awesome, awesome, awesome stuff. Coaster enthusiasts, if you want a career in coasters or engineering, you better take major notes on this. That is how coaster engineers figure out information. They use kinematic equations and dimensional analysis. Totally neat stuff. I hope you guys enjoyed this video, and we'll talk to you soon. The Coaster Man signing out.